Hi, and welcome to Git for DBAs. This is a simple introduction to Git with Flyway. My name is Kendra Little, and I'm a DevOps advocate with Redgate. And in working with DevOps and databases, I find that a lot of DBAs are not comfortable with Git. And in this presentation, I'm going to first talk about why I think that database administrators really benefit from learning Git. And we'll also talk about what Git is, a little bit about how it works, right? So we're going super high level here. I'll then talk about how you can get set up and practice with an implementation of Git, because this is one of those things where you really learn it by doing it. And I actually think it's a lot of fun as well. We'll then dig into essential Git commands to learn as you begin. And then finally, we will go through references and discussion. So first up, what is this? Why do you care? And how do you do it? Well, let's cover the why first. When I first started working with databases, I relied a lot on file shares. And the thing about file shares is they are a way that you can share information with people, but a lot of accidents can happen. Hey, how did that file accidentally get into a subfolder? Did I accidentally click that and drag it? Did someone else? When did it happen? How did that thing get deleted? File shares are not really designed to help make sure that you mean to make changes, right? They're really, really simple. Also, Git is not only a much more reliable way to make changes, share changes, and track what happened, but also it's very, very broadly accepted as the most popular version control system these days. That's not to say that other VCSs aren't good, but in terms of what to prioritize learning first, whatever you do in your career, you're likely to find that knowing or being familiar with Git is really, really useful. And in terms of the work of DBAs, this has everything to do with common scripts that you run, to configuration files, to code for your databases, as well as any applications that you may build. So there's lots of things you may do with this. And I think you'll also find that a lot of automation kind of expects that you're maintaining files in source code. Everything from we're going to automate infrastructure as code and start to be able to automate building out servers and databases and parts of your environment. Everything from that to we want to develop and deliver applications. So I do think investing your time in learning Git as a DBA is really, really useful. In terms of what Git is, one of the most important concepts to think about at first is that Git is a distributed version control system. And what this means is when you think about how Git works, and this isn't true of all version control systems. There's kind of different styles of version control systems. With Git, there is an upstream repo, and there's downstream local copies of that repo. So when I'm working in Git, I might be working in my copy of the downstream repo here. Maybe my colleague Kathy has another copy of the repo on her laptop here, and Kathy might also have a second copy of the repo. Maybe it's a separate copy on her laptop. Maybe it's on a desktop somewhere, right? We can actually have as many copies of this repo as we want. Now, for the demo we're doing here, you'll only actually need one copy. But what you're doing is when you're creating a local copy of the repo, it's really just a folder on the workstation or machine you're working on, right? So you can actually create multiple of those. And what happens is you make changes in your local copy of the repo, and you can push them upstream to the upstream repo. And that's how you share changes with other people. If I want to share my changes with Kathy, I make my changes in the local copy of the repo, I push them upstream, and Kathy can then pull them down to her copy of the repo. Now, Kathy can also, one of the nice benefits of Git, since it's distributed like this, is we can actually work disconnected. I can work in my local copy here, and even if I don't have an internet connection, depending on, where the upstream repo is, I may need an internet connection to push to that upstream repo. But since I have my own local copy of the repo here, I can work disconnected for a while, and then when available, I can push up to that upstream repo to store my changes there. There's multiple benefits to pushing to the upstream repo, right? As long as my changes are only here on my local repo, what happens if my laptop is destroyed and my hard drive is lost? Well, if I haven't pushed those changes upstream, I might lose those changes, right? So pushing my changes to the upstream repo has the benefit of putting them in another place, hopefully one that has some high availability to it. But also it means that I can share it with other people. Once it's in that upstream repo, others can pull that change down. So this is what we mean by saying that Git is a distributed VCS. Conversely, if I want to know what changes Kathy is making, I need Kathy to push her changes to the upstream repo, and at that point, I can pull them down. Now, there's a variety of flavors to Git. And by flavors, I mean implementations. You can host Git yourself if you want. Right? So Git is freely available. You can download it, and you can host your own Git repo if you like. A lot of people do use a hosted solution. Either they use a cloud provider that hosts Git, or they use a tool that may automatically kind of help manage the repos for them. Here we have a lot of the popular implementations of hosted Git that you can use. GitHub is the one that we'll be using in the demo today. GitHub is very, very popular, especially for open source projects. And it has some optimizations that make it easy to do things like one of the things you often need to do with an open source project, or one of the things that is helpful with it, is you want to make it easy for people to make a copy of an entire repo and then work on it on their own, and then maybe share their changes back with you. So GitHub has implemented a way to do this that's called forking the repo, and we'll be using that for convenience today, because if you want to follow along with these demos, you may want to fork the sample repo I have and then play along with that. And you can do that all for free, so I'm demoing that with GitHub. Now, some of these other implementations also have similar features, but implementations kind of vary a little bit depending on what types of people kind of use that Git implementation, what they've found really useful, stuff like that. Now, before I leave this page, I do want to mention GitHub gists, just because these are their own special kind of thing. And gists, I'll go to gist.github.com. I realize you can't see my browser yet. Or actually, let's go to gists. There we go. I'll just search for it and have there. It is gist.singular.github.com. So gists are really, really useful if you want to share just a file or two. So this is a really simple way that if you have a GitHub login, instead of creating an entire repo, you can create a public or a somewhat secret gist, right? Like anyone who figures out the URL can see your secret gist. So this is only sort of quasi-secret. Usually I would do public gists. Like if you want to just share a couple scripts publicly, but you don't want to create an entire repo, gists are really, really useful for that. Lots of folks use them. You can browse all sorts of gists in different languages there. So we won't be doing a big demo of gists today, but I did want to call that one out because there are absolutely, even though I like using repos, there's times where I just want to share a single script. And so gists are a very, very useful way to do that. Now, what about how do we make databases make sense with Git? This is one of the reasons I think that folks who are database administrators don't always learn Git right away, is that it's not extremely obvious how to use Git with database code. There's multiple tools that can help you do this, because in terms of storing database code in Git, the question is really, well, how are you going to use that code? Some folks do just want to say, okay, we're going to kind of use source control as kind of a breadcrumb trail. We're going to find some way to capture the code in the database and then put it in version control on a regular basis, just so we can kind of tell, well, it looks like that changed on Thursday afterwards, right? At least we're not just relying on database backups to figure out when something changed in the database. But that's not bad. There are good things about that, but it still isn't perfect, right? It still doesn't tell you, well, who changed that and why did they change that? And exactly when did they change that? Was it tested before it was deployed? So having a tool that allows you to not only capture the database code in version control, but also capture it in a way that allows you to deploy the code as well can be really, really useful. And different tooling can provide a different amount of features. There's some tooling that helps you auto-generate the SQL and makes sure you're storing it in a consistent fashion. There's some tooling that also helps you with continuous integration and continuous deployment. And this helps you do things like, let's build the database code and prove that everything compiles and executes successfully, and output a build artifact from that code that we can use for testing and that we can use in deployment pipelines. Some tools also support a large variety of different databases, while some tools support and specialize in one type of database. So there's all sorts of different tools out there. Some are free, some cost money. I want to show you free, simple tools to get started today. So we aren't showing a tool that has all of these bells and whistles today. I'm going to show you a simple deployment tool called Flyway, right? So it doesn't help you generate the T-SQL. It doesn't do continuous integration or work with automated testing or that stuff. It does let you work with a variety of different databases, right? It supports, if you want to work with CockroachDB, if you want to work with Azure Synapse, if you want to work with Postgres, it will help you deploy code to a lot of different relational databases. We'll be looking at SQL Server in this demo, but it really focuses just on, I want to deploy some scripts, right? So I think for DBAs, this is really useful in terms of getting started, to start with, yeah, I want to learn how to use Git, but I also want to be able to do something with it, right? Version control is more useful if we can actually get our hands on it and do something with it. And that's why I'm also showing you a simple deployment tool, and one that has a free community version. It is an open source tool. It has a free community version so that you can get started and actually not only put some code in version control, but if you want to deploy it, you can actually automatically run that code too. All right, so how do we get started with Git? How do we get set up? There are so many tools that you can learn Git with. And I'm going to show you really two tools today. And I'll be showing it all in the context of Azure Data Studio. Azure Data Studio is a free tool from Microsoft. It's built on top of VS Code. So it has a Git client in it that is the same Git client you'll find in VS Code. So all of the Git functionality you see me do in Azure Data Studio, like you could do the same functionality. It's the same client in VS Code. I'm using Azure Data Studio because they have this really cool notebooks feature, which I can use the notebook and follow along with it, and I can share the notebook with you in a Git repo. And then if you want to follow along in the notebook, you can do that as well. So that's part of why I picked Azure Data Studio. I'll also be using the Git command line interface a little bit. There's a terminal in Azure Data Studio, so you can also use the Git command line. I really like the Git command line, and I use both it and the graphical interface in Azure Data Studio. And I find it very comfortable to kind of do some things in one sometimes and some in the other. And I think you might find that as well. As you're learning, it's totally fine to use the GUI, but you may find you like to use the command line for a few things as well. And as time goes on, you may develop kind of affinities with one or the other. And I think that's natural. You don't have to only use one tool. There are many other tools out there. I like both of these because they aren't overwhelming. They provide a lot of functionality without having so many different options. Git can get very complex. That I find that these don't overwhelm me too much, and they cover most of the things that I do all the time. So we're going to get started just by saying, okay, well, how do we create our repo and get going? So let's bring our browser back over here and let's go to GitHub. Now, this is just the one I'm using for demo. As I said, there's a lot of different implementations of Git out there, and I actually like more than one. I think GitHub is great for sharing things openly because so many different people use it. I am signed in with my own account here. You can create an account for free. So after you create your account, head over to this repo, which is Git for DBAs. And what you want to do is you want to fork it. So here at the top right, there is a fork button. And if you hover over it, it'll tell you what it does. So fork will allow you to create your own copy of the repo in your own account. So instead of it being Litkin's copy of Git for DBAs, it will create one that is yours. So I'm going to click on fork, and it asks me, where should we fork this to? Now, Git won't let you kind of fork a repo within your own account. I have an organization in Git that allows me to demo forking. So I'm going to click it to my database DevOps organization just to show you a little bit about what forking looks like. I absolutely love this graphic of a copier with a fork on it that's happening. But in the time I had that zoom done, it has already forked it. And you can now see that this copy of the repo is in that separate org. So you can do the same thing to fork it to your account. And it even keeps, it can tell you, oh, this was forked from that original one there. And now that you've forked this, you can do all the steps that I'm going to do and make changes to this and push and pull and do pull requests and experiment and learn on your own in your forked copy of this repo and follow along with the demo. Now, I don't actually need to keep this forked repo, so I'm going to go ahead and delete it. It's very nice about letting you delete things all the time. So I'm going to go ahead and go back to my organization here, and I'm going to take my Git for DBAs project. I'm going to go into settings, and I can actually scroll down to the bottom here and say I want to delete this repo, and I just have to make sure that it's okay for this, and I want to go ahead and tell it that it's okay to delete that repo. Right, so anytime you want to delete a repo, you absolutely can do that. So we go back to my repo. You'll work in your forked copy of the repo. So now you've got a copy, and what you want to do is you want to clone your copy down so you can work on it on your machine, right? Because this is a distributed system. This here on GitHub itself, this is my upstream copy of the repo. Your forked one is your upstream copy of the repo, and I want to clone this. If I click on this green button here, there are a variety of ways to do this. Now, if some folks like to use the GitHub desktop app, that's totally fine and good too. I'll be using Azure Data Studio instead. So what I'm going to do is I'm going to copy the URL from just the HTTPS URL from here and just use the URL to clone it. So I'm going to click the copy button here. And I'm going to go into Azure Data Studio. There's a couple different ways I can do this. So I can go here. If you look here, this little icon here is the source control extension in Azure Data Studio. So I can also get to that with Control-Shift-G. We'll also open that up. And notice that it says, oh, well, there's a clone repository button. This is what I want to do. I want to clone my repo. If I have already cloned the repo to my local machine, I can just click Open Folder here, right? So in the past, if I've cloned this, I can just open it. I only need to clone it once unless I want multiple copies of it. But let's say I want to go ahead and clone this repo. Now, if you click here on clone from GitHub, you can actually, there's a feature that lets you sign into GitHub and browse all your stuff. I'm just going to pop the URL into here. You don't have to sign in from GitHub to clone it. So I'm going to pop that URL in there, hit enter, and it says, well, where do you want to store this? I like to keep mine. I have a folder on my C drive named Git. I like to keep mine in there. And I actually do already have a copy of this here. Just for demo, I'm going to call this another slice in honor of one of my favorite TV shows, Great British Bake Off, an extra slice, and say that's where I want to clone it to. And it says, oh, wait, that path doesn't exist, actually. Sorry. I've actually messed up here, but this is a nice, I should have explained this. What we select is we select the parent folder to where we want to clone it. So if I select the folder Git in this thing, it's going to put it in the folder itself. And notice that I already have a folder named Git for DBAs in there. So if I'm going to create a new folder here, and I'm going to call it just for demo. We could put extra slice if we wanted in there, but I think that joke is done. So I'm going to click on just for demo. And what I'm saying is I want to clone, this is going to be the parent folder I'm cloning into. There we go. Now, if you do want to make your local folder of this have a different name, there is a way you can do that from the command line. If you want to have multiple copies of it, each with a different name, you actually can. But the way I was cloning from here, you just choose the parent folder. Now, it did prompt me down there as to whether I wanted to open it, but I was too slow. So I'm going to say here, open folder, and I can go into just for demos, and I can pick Git for DBAs, and I can open that there, right? But in truth, I'm actually going to close this out. I'm going to close folder because in truth, I actually want to go ahead and use the one I already had downloaded. But I do want to show you that anytime you want to clean up or remove a repo, it's really easy. You just delete the folder. So I'm just here in Windows Explorer going to say, oh, delete that repo I just cloned down. I just deleted my local copy of the repo. I can delete the folder that it's in too. And I can do that and reclone it at any time. Now, of course, if I had made changes to the files in this folder, I would lose it, right? So if I want to be careful about deleting a repo, and if I'm worried about losing changes in there that haven't been pushed up to the central repo, but if I'm confident, not going to lose anything, it's no big deal to delete it. So I'm just going to pick this repo that I have been working in before that has already been cloned from my repo. And I've opened it up, and we can start working in there. Now, inside this repo, I have, if I go to the Explorer button here, it will help me look at what are all the files in this repo. And we can see I have a notebooks folder that has 2 Jupyter notebooks in here. I've got a folder named migrations that has some SQL files. We'll be working with those. Those go with Flyway, and we'll be demoing that. And we have a README and a license and other good stuff like that. These are the same files that if we look at the repo, right? Here's our notebooks folder. We could dig in there and see those Jupyter notebooks. Here's our migration files, right? It's the same files that I'm seeing there. And one cool thing about these Jupyter notebooks is if we look at like the Learning-Git Jupyter notebook, not only does this display in Azure Data Studio, but also you can browse it on GitHub. But there's some extra functionality that we can do in Azure Data Studio, like these special blocks here. We'll actually be able to execute those if we want. So that's just real quick on, we forked the repository first on GitHub, and that allows you to create your own copy of the repo that you can work in. But that forked copy of the repo, it's your central or your upstream repo online. And then we grabbed the URL of that repo and cloned it locally so that we have a local copy of the repo we can work in. Before we start making changes in there, I want to explain a little bit about why I'm including some Git commands and why I'm including a workflow that might seem extra to you, but I don't think it's extra. One common goof that I see people make, one common thing that seems natural but ends up causing a problem is that people tend to think that, well, all right, I just want to learn the basics. So I'm not going to learn branching and merging. Maybe I'll do that later. In my opinion, branching and merging are part of the basics of Git. They are absolutely essential because Git wants you to branch and merge. In other words, I think it's actually harder to work with Git if you are not branching and merging. And a pull request is a special form of merging. So we'll talk about branching and pull requests a lot. Pull requests are a way to say, I am requesting to pull my changes into another branch. I'm requesting to merge into another branch. And here is why I say it's easier. As we've talked about, Git is a distributed workflow. So let's say my colleague Kathy, she's working in her local copy of this. And let's say that we decided, yeah, we'll learn branching and merging later. We're just gonna, like when you first create a GitHub repo, it has a default branch. That default branch is named main. You can have whatever you want as your default branch is the truth, but let's say that we're just working in this default one that's named main. Sometimes people refer to the default branch as trunk. You might hear people say that word. You might hear people say master, which sometimes is the name of the default branch. In GitHub now, when you create a fresh repo, it will give you a default branch named main. So let's say Kathy has made changes in her local repo, and she has committed those changes. You'll find that to do that, what Kathy does is she stages her changes and then she commits them. And she has then pushed them up to the central repo to share them. That's great. That's great. But if I'm also working in main, this actually might be kind of a pain for me. Because if Kathy has pushed her commits to main and I have also locally committed to that same branch, it actually doesn't matter that it's main. It matters that it's the same branch. If I have committed to that same branch and then I try to push to the repo is going to be like, oh. Something else has happened in main. The version of main that you're pushing to is not the same version of main that you based your changes on. And then sometimes if I try, I'm like, okay, well, I see that I can't push. I'll pull from main. Sometimes if Kathy and I have updated some of the same stuff, it'll be like, oh, actually, no. You have a conflict and you can't pull either. You have to resolve this stuff before you can pull, right? So it's like almost like a deadlock. And there are ways to resolve this. You aren't stuck forever, but it's just awkward. It's a fairly complex set of commands and you just got to kind of go through it. And it's just sort of a pain. And there's also other problems with this too. So yes, you could work that out, but it's just sort of, and sometimes if you're working with tooling that interacts with Git, it gets sort of mad if you get into this situation too. But there's other reasons we wouldn't want to work just in main as well. Perhaps, a lot of times what people want the main branch to reflect is either the state of production or a state of code that is good enough to be shipped to production. Right? The idea is that you should have that your main line of code should always be deployable, should always be of quality. Well, I don't know about you, but my first draft of changes isn't always of quality. But we still want to be able to commit our changes regularly, even if we're not sure they want to deploy. Working in another branch means if I'm not working in main, if I'm working in another branch, that, there's no assumptions that my other branch, which maybe is named like Shmoo or feature 1 or feature 2, I can commit as often as I want to that branch to save my work. I can even push it up to the repo and share it, right? Because it's not in the main line of code. It's in an experimental branch. And being able to commit regularly has big benefits. I might want to look at the code. Oh, I don't like what I just did. I want to go back to the code I did 3 commits ago. I can do that, right? And so working in our own branches has a lot of benefits for helping us to experiment. So it also helps us manage these conflicts better. So the process that most folks follow, and we're going to follow this process in our demo, is that when Kathy commits her changes, she would commit her changes to something maybe called a feature branch, but a place for her to work in that is her own branch of code. And when she's ready to share her changes, she probably does actually a few safety things first, right? Depending on how long Kathy's in the boop branch, depending on how long Kathy's had that branch open, right? Other people might have merged stuff to main. So she probably wants to pull down, okay, what's the current version of main? And she might merge the current version of main into her branch to make sure she understands, okay, what is the main line of code? Have I really looked at stuff? But when she is ready to share, she pushes her branch to the upstream repo, and then she takes out something called a pull request that says, I am requesting to merge my changes in from the boop branch into the main branch. Maybe there's automation that kicks off at that point to validate her code. Maybe I get a notification to review her code and have a look at it before it merges in, and then she merges into main. Now, I also am working in my own branch. Let's say my branch is called Shmoo, right? So I've committed in Shmoo. When I'm ready to merge my code into main, I can pull down main, and similarly to what Kathy may have done, I'm like, oh yeah, I think I'm ready to go. But what else has happened lately? I pull down main. I see, oh yeah, Kathy has there's some stuff has changed in there. I can merge that into my branch, make sure that Kathy's changes make sense with my changes. And then I can push my code up there. I can do a pull request to merge into main, et cetera, et cetera. So this way, Git likes you to work in this way. It likes you to work in a way where if I do have a conflict when I'm merging main into Shmoo, I can examine that conflict. I can work with it. I can decide, if in a conflict meaning, maybe 2 people have changed the same file, I can decide which of these should I keep. Do I want to combine the edits to them? Do I want my edits to overwrite? Do I want their edits to overwrite? But I can decide that, update my branch with it, push it back up, and then merge it back in. So we have a record and a path for everything. Everything kind of goes on its own road. Like I think of people working in the same branch as like traffic on a one lane road, sometimes really awkwardly having to get around each other. I think it's much more, and working with Git, it encourages you to have separate streams. You always have your own lane that's going one direction and you merge. So let's take a look at what this looks like. Back in Azure Data Studio, I've pulled the changes down and I'm going to open this Learning-Git notebook. So this is the Learning-Git-ipynb. This is a Jupyter notebook. Jupyter is spelled with a Y. So that's part NB stands for notebook. Not sure what the I stands for now. Down here, I have my terminal open here in my PowerShell console. I actually am going to click the plus here just because I want an updated version of my console, which is called just the PWSH. Notice that I have some special highlighting in here. It's saying you are currently on a branch named edit README. I was working in this earlier, and I can actually, in Azure Data Studio, at the bottom down here, notice that it's saying you're in this branch, edit README. So to get started, I actually want to change branches here. I'm going to close my terminal here just because we'll use the terminal, but we don't have to use it first. To change branches, there's a few ways to do this. You can click on the branch name in the bottom left. So if I click on the branch name in the bottom left, it brings up this the menu palette here at the top. And it says, well, what do you want to change to? What branch do you want to check out? And I have a couple options here of different, these are my local branches I can check out. And then it's also kind of gone upstream and looked at what are the upstream branches up there too. Now, my main branch is actually the branch I want to check out. So I'm going to do, and I can also, there are many ways to get places. I can do Command-Shift-P to bring up that command palette as well. And I could type get check out to get to the checkout menu there too. But wait, there's another way, right? So if I click enter there, it'll prompt me for the branch. But also, I can go over to the source control tab here. Remember, this one's also Control-Shift-G. And if you want to start really with the GUI, maybe you work a lot from this source control tab there. That's fine too. And in the menu here, I can say check out to, and then I could say click on main there. Now, how do I know what branch I'm on? If I have source control repository showing, it'll show my branch up here if you have that menu showing there. It's also always at the bottom left of the screen. It took me a little while to kind of get used to looking at the bottom left of the screen. That wasn't super natural for me, but it's there. And it also tells me, hey, there's 3 changes in the main branch in your central repo that you haven't pulled down yet. These are actually changes I made right before I started recording. So I could click right here to synchronize the changes. If you click synchronize in VS Code or Azure Data Studio, it will push and pull. I don't actually have any changes to push, so in this case, it would just pull. But also we could go here and click pull as well. And now we can see, hey, we are fully synchronized, right? There's nothing like here indicating that we're missing. So in this notebook, it covers things we've already done. So it first covers how to fork the repo, how to get Git locally. And looking at this, I realized I did skip a step, right? If you haven't installed the Git command line locally, you do need to also install it, right? So I'm using the client here in Azure Data Studio, but I also need to install Git. It is super easy is the good news. So if you want to install it through the website, you can open just the free Git website and download it for your platform. Azure Data Studio does itself work on multiple platforms too, so you don't have to be on Windows here. Or if you are a chocolatey user, chocolatey is a package installer that makes it really easy to install things. You can do choco install Git or choco upgrade Git. So what I'm doing is I'm starting up a Windows terminal. I have run this as an elevated prompt. So, run as administrator. And I'm going to say choco upgrade Git. And it says, oh, you're actually on the latest version. So I find Chocolatey really, really useful. Check out their website, chocolatey.org. This is a Windows tool, a Windows package manager. There's other package managers for other OSs. Chocolatey is Windows specific. But if you are a Windows user, you may find Chocolatey really useful, not only for installing Git, but also loads of other tools. All right, so that's installing Git. We did show cloning the repo. And now we are actually going to make some changes. So first thing we want to do is we want to make a new set of changes, but we don't necessarily want to do it in the main branch for the reasons we discussed earlier. So we want to check out a new branch to do it. Now, if we want to use the command line, I just did Control and then the weird little asterisk-y thing to open the terminal. If you want to open it from the menu, it is here in the menu somewhere. Oh, it's under View. Yeah, here it is. So now you can see the weird little asterisk-y thingy that I'm talking about, right? So anytime you want to open the terminal, you can do either View Terminal or Control plus really high back accent. I'm sure it has a real name. But the terminal, I really like. And what I've got installed in the terminal, if you want to get a little fancy with it, it's not that fancy. In PowerShell, I have a couple things set up. I installed posh-git. I actually installed that with Chocolatey. This is a tool that can help PowerShell work with Git. And then I also installed something called Oh My Posh, which helps format it as well. And I have set a theme to Paradox. So if you want to make your PowerShell command line in your terminal do these things where it shows you, hey, you're in this repo and you're in this branch, that's a little bit about how you do that. It also helps give you some neat things like some autocomplete functionality as well. So I'm just going to clear the terminal with CLS, and I'm going to say git. Right, here's the command I'm using here. If you want to change branches from the command line interface, you can say git checkout. If you are creating a new branch, you do -b. That says create a new branch with this name. If you want to just switch to an existing branch, you don't need the -b. In fact, it'll throw an error and be like, no, that branch already exists. So I'm going to create a new branch. I'm going to say get -b, and we'll call this features new SQL file, right? Oh, I forgot the word checkout. So I actually think the get command line is pretty helpful. In this case, it's just like, I don't know what -b is, but here are some of the flags that go just with the get command itself, right? But it is like, normally people put a command here. The command, so I'm going to do arrow up to get that line back, and then I'll just edit it, right? Because I forgot a verb. I want to check out a new branch with this name. And if, let's say I misspell it. So let's say I do check out, right? It says, oh, well, here's the command that I think you might have meant. Right? So I think it's a little bit friendly. I like that. And I do often not get the command right the first time. So I have now switched to a new branch named features new SQL file. And because I've got those little helper things installed, it says this on my command line too. We can also see in the bottom left of Azure Data Studio that that is the branch I'm in. All right, well, what if you don't want to use the command line? That's fine. Let's do a similar thing. So I'm going to click here in the bottom left, and I'm going to say, oh, I want to create a new branch. One of the nice things about creating a new branch here is, let's name it, this is really the name I want. Notice that I put spaces in there and hit enter. We're not allowed to put spaces in branch names, but it was kind enough to automatically put some hyphens in there for me. So I think that's actually a really nice feature. So I can be in that branch. Well, what if I want to see, what if I want to delete that other branch that I was in? Now I just did Control-Shift-P to get to the command palette. And what it's doing is it's showing me all of my recently used commands. If you haven't run these recently, you might not see them there. To see all of the git commands, if you type git there, it will show you them even if you haven't run them recently. So let's say I do want to delete branch, right? But maybe if it's not showing the list, you can just type del. Okay, I want to delete branch. And see here, I can select different branches. Let's delete fixie-uppy. Now I'll do Control-Shift-P again. Delete branch is my most recently used commands. I can click delete branch. Oh, okay, I actually want to delete edit readme. Okay, I'm really cleaning up here. Control-Shift-P, delete branch, features new SQL file is gone. So that, I think the command palette, a lot of people really like using this because of that ability. As long as you get used to hitting Control-Shift-P, once you get a lot of frequently used commands in there, you can just arrow down to them, right, and select them. So that's really convenient. If you are more comfortable using on this source control tab here, if you are more comfortable using this menu and using the checkout button, of course, that's fine as well. You can say checkout to, you can say create new branch. Now, one important thing to know is notice that we have this option of create new branch from. If we just say create new branch, what does that mean? That means that the branch that we are currently on, in this case, I am currently on, this is really the name I want. If I just say create new branch or check out new branch, it will base it on wherever I currently am, right? Maybe I want to create it based on main, though. What I tend to do in reality is I tend to always go back to main and pull down my changes. So I'm going to do Control-Shift-P. I'm going to say I want to pull all my changes from origin and go ahead and pull those down. Or you can just, of course, hit the synchronize button. But I tend to go to main, pull everything down, and then create a branch off there, assuming that's where I want to create my branch from. All right, so let's do it. This time I'm going to click here on main. And let's go back to, this is really the name I want. Let's actually go ahead and put our changes in there. And let's make a change. So we want to change. We're going to add a new migration script. Well, what's a migration script? We're going to go to the Explorer. You can also do Control-Shift-E, or you can click there. We're going to look at these SQL files that we've got. So if we look, we have currently 3 SQL files in there. We've got v1 initial. This, by the way, is 2 underscores. This is important. The Flyway tool reads the file names, and it uses the file names to understand what scripts to run and what order to run them in. So the 2 underscores are important. Notice that after v1, I have 2 underscores. After v2, I have 2 underscores. And then I did v2.1 and then 2 underscores, right? So it will actually run v.1 first, v.2 second, and then v.2.1. The words here are really for me. Those are for a human. These aren't very helpful in this case, but in theory, you would name these well, and they would help a human recognize what the script does. So v1.initial is creating a table named Hello World. v2, YOLO, is inserting 3 rows into Hello World. And then v2.1, which I really just named it that just to show that you can do, kind of 2 dots. You can do incremental ones if you want. It is creating another table named I like DAGs. So let's insert some stuff into I like DAGs. So because I'm kind of lazy, I am just copying the script from the YOLO script. And I'm going to right click on migrations and say new file. And we're going to name this v2.2. Let's just call it insert rows in I like DAGs.sql. We could create different things, right? We could do all sorts of schema changes or data changes. But I'm just going to say, I'm going to do insert dbo.I like. I should have used a schema in the other one. Tags. And it also does have a declaration column that I can insert into. Let's put some different values in here. Will be I also like DAGs. I think this is a Fight Club reference. I think this is a Fight Club reference. They say never talk in a demo. It's probably just boring to watch, but there we've made some changes there. Right, so I've added a new SQL file here, and notice that they've changed color. So this is a nice thing about this client. It's saying, hey, this file, there's change here. We've done some changes in the migrations folder. And here on our Git icon, it's telling us we've changed one file as well. All right, so let's click on our Git icon. And this is just showing the files that we have changed on this. Now, in order to share these files, we need to commit them. But before we can commit, we should change. So one nice thing, if we want to put our commit messages in here, I'm going to say, am I ready to commit, ? You would use a better change. And then if I hit Control-Enter, it points out to me that I haven't done the necessary thing. It says, you have not staged any changes to commit. And it gives me the option of, do you want to automatically stage them? So I'm not going to say yes. You might want to say yes. If I had multiple files, why would you want to stage changes? Well, we need to say, which files do we want to commit? Maybe I have made changes to 4 files, but maybe I don't want to commit them all. Maybe I, I'm still playing around with the other 2. I'm not sure if I want to commit them for whatever reason, right? So I can stage individual ones. If I hover here, a little plus button will show up. I can selectively click this button to say, Yes, in this case, this is a new file. So I've staged the file and it says, oh, you are adding this file. This is a new file. So it's not, an update of the file, it's adding the file. And I have one staged change here. If I want to unstage it, there's a minus that shows up. So now I have unstaged my change there, right? So it still says one. I have one change here, but none of them are staged, right? So now I have one stage. So I'm going to say, I am ready to commit. I'm going to do Control Enter, and that automatically commits it if I'm using that message there. I could also have gone here to the menu and said commit at that point. If I do it now, it's like, well, you haven't changed anything since I committed, right? If I want to undo my last commit, I can go to commit and say undo last commit. And now it has undone that last commit. But this file is still staged, right? It undid the commit, but the file is still staged. Okay, I really do want to commit. I'm going to do it with the command palette this time. I'm going to do Control-Shift-P, say get commit. You can say get commit there. And I already had typed my message in there, so it didn't prompt me for it. If I hadn't typed a message in there, it would have been like, well, what do you want your commit message to be? So let's undo that commit, just so I can show you undo last commit. I'm going to bring up the command palette here. If you like to commit via this, you can say get commit. Because I have posh-git installed, I can use tab to autocomplete. I can say -m. I need to, if I do it without a message, it'll open an editor and be like, oh, you need to do a commit message here. Now, I almost never use this editor, so I'm always like, oh, how do I get out of this editor? Okay, this is my commit message. And then I'm all, like, notice that it's not like, I feel like it's Control X or something like that. Q. Control Q. Oh, there is a way to get out of that editor. I always have to look it up. So I'm actually just going to kill the terminal and then reopen it. So what I normally do is get commit -m. This is my important commit message, right? And that commits without opening whatever default editor I have installed that I am terrible at using, right? So now I've actually committed there. All right, I've staged, I've committed locally in a variety of ways, and now I need to push up to my central repo. I could push this button here to send them up, right? If you highlight there, it'll say, and it's going to push it up to a copy of the branch I have up there. I could go to this menu here and I can say push. And when I do that, it says, oh, this doesn't have an upstream branch yet. The upstream copy of the repo does not yet have this branch. So you need to create it. Do you want to publish the branch or create it up there? So I could say, okay. And at that point, it would create the branch in my upstream repo and push it. Or if I want to do this from the command line, I could say get push. Now, similarly, it says there's no upstream branch. And I think this is part of how the command line is really helpful, is it says, oh, if you want to use the same name upstream, here is, you can copy and paste this text. And this is the text to say, push this upstream and create the upstream branch, right? So I never try to remember this. I always just say get push if I'm using the command line and then just copy what it has. Copy to the, paste it in and then hit enter. Or I will simply use one of the ways to do this via the GUI option. So let's do command palette. Let's do get push. Let's say, okay, we do want to do that. And that's really convenient. I was able to do all of that from the command line. If I was already in the terminal, I might have used the terminal, right? There are many ways to do this. So here we are. Let's go back up to our repo, wherever I've put my repo here. And all right, we'll say GitHub. Go back to GitHub. And we want Git for DBAs. this is really, really helpful. And it says, oh, by the way, you just pushed changes to, this is really the name I want. Do you want to compare this branch to a place you want to merge your code into and create a pull request? Why, yes, I do. If I am ready to merge the code, then I want to create a pull request. So this opens the pull request. And part of the value of doing a pull request is I can document the reason for this here. There may have been 10, 15, there may have been multiple commits as part of this. I can sum up what the point of this all is in the pull request itself and create the pull request. Perhaps I have automation that might kick in and validate my code. Perhaps I might have automatic reviewers assigned to this, right? I could have all sorts of stuff that this pull request did. In this case, we're starting simple. I am my own reviewer. I am ready to merge it in. So I'm going to click Merge Pull Request. I can put reasons why here or edit it to make sure I want, to document how this is. And then I can confirm the merge there. So now I've merged it in. Do I still need the branch I was working in? I don't. Actually, I'm going to go ahead and delete the branch because I don't need to keep it around. And now if I go back to my code and I look in my migrations, I am in the main branch and v2.2 is there. So I have v1, I have v2 and v2.1 and 2.2 all there. Now back in Azure Data Studio, I'm still here locally in my local copy of that branch. I'm going to switch to main. So I like to do that with Control-Shift-P. Of course, you can do it from checkout here. I could say checkout to main there as well. And notice on main, I haven't pulled down the changes yet. I need to pull those changes down. In this case, I just clicked the button there to do it. I could also click pull. And so now main has those changes and is up to date here. Well, let's actually look at running that code. So I mentioned, I think with, it's not just about we want to make the code useful and runnable. Let's look at that notebook I have on Flyway. So Flyway is a simple code runner for SQL scripts. And what I'm going to be using for Flyway is there's a couple ways you can run Flyway. You can install it. I actually wanted to zoom. I didn't want to do that. If you want to just, I'll be using the Docker container. But if you don't want to use the Docker container, you don't want to install Docker or whatever, you can just download and install Flyway itself really easily. There's a free community version. It will prompt you for an email, but you don't even have to give it. We are going to be using the Flyway Docker container, which is also free. You do have to install Docker wherever you're going to be running this. So I have Docker here. It does need to be running. Let's see, Docker. There we go. So I just have Docker desktop running on Windows. So we can see here's my Docker. No containers are currently running. And here's the first command. This is a PowerShell notebook. Here's the first command we're going to run. And it's just Docker run --rm flyway. The RM is just saying when you exit, don't leave the container around, right? We're just going to start up the container, run Flyway, and then when we exit, clean up. There's the cleanup bit. And running Flyway in this way just prints out, Flyway just prints out, oh, here's all of the commands you can use with Flyway, right? So this was just a test run to be like, okay, is the container working? Like, kick the tire. But here's the Flyway commands that you can run. Migrate is going to use those migration files against the database. There's lots of, I'm not going to be able to tell you everything about Flyway in this video. There's lots of documentation about all of these commands on the Flyway website. So our container is working. We can do a quick, simple test using an H2 It's an in-memory database. This should actually have a hyphen in there, but we'll leave that alone for now. We can run a test of it that way if we want to, just to be like, this time we said, run the container, clean it up after. Here is the URL of the database to talk to, and then here's a user, and we're running the Flyway command info. So Flyway info looks at this little in-memory database, which just automatically ships with the Flyway container. And it's like, oh, well, I looked at that, and we haven't done any migrations to that thing. Well, we want to talk to a SQL server, right? We want to run our SQL Server scripts against a SQL Server. So how do we do that? We can, and in this case, I've just run the command across multiple lines for convenience here. I'm adding 2 volumes in. The first volume points to a config file. The config file says, where is the SQL server I want to talk to? How do I connect to it? And what is the user and password? You will need to edit that config file. It's in the repo. You'll need to edit to point to your SQL server and have that yourself. Don't check your login info. I just have no important things on my SQL server. So I did check my super secret password in. It's okay if you see that. And then this Flyway SQL, this is where the migrations are. So you will need to edit wherever you put your repo, you will need to edit this absolute path to where the repo is, where the migrations folder is, and where the Flyway conf folder is. And we are running, again, the Flyway info command. So it's going to look at, notice that what it did here is it looked at those version 1, version 2, version 2.1, and 2.2, and it looked at the target database and it said, have these been run against it yet? Because migrations, these types of migrations will only ever be run once, right? I can only create I like DAGs once. I could alter it in a later table, but I don't want to keep trying to create a table over and again. So these are all pending. They have not been installed yet. If I actually want to execute them, this is the same command as before, saying here's the config file. Here's where the SQL files are. I can run the migrate command. And now it will actually go run against the database and say, I am migrating. I'm actually executing these. It applied 4 migrations there. So if we want to take a look at these, let's take this is just a little bit of SQL that we can open in a new window. I can connect to my local instance in Azure Data Studio. And I just want to, one of the tables we created was called Hello World, right? This is what the schema looks like. And we can look at Hello World and see, oh yeah, it did put rows in Hello World. Similarly, what another table was, I like DAG. So if we look at that, that table exists and it has rows in it as well. So Flyway is a simple tool that we do want to be able, I think this is particularly useful for DBAs because as a DBA, you might want to have just a few scripts that you install regularly in a bunch of different databases. You don't want to touch the rest of the database, but there's just a few things you want to migrate. Flyway can be a great, convenient way to get started with that and to be using source control, maybe start to make your way into a little bit of automation. Now, Flyway also has a clean command. Be very careful with clean because it will drop everything. It's essentially resetting my demo for me. But notice, yeah, clean does light everything up. There's, by the way, in the Flyway config file, I'm going to go ahead and run this, but in Flyway has config file. In the config file, getting a little excited here, you have an example of Flyway conf here. You can see my super secret name and password. I swear I have nothing on this instance that's of value. There's a parameter you can put in here. This is, by the way, never run clean against this instance to block it, which you would want to do for config files for production instances. Obviously, you would want to do things to not put passwords and usernames in. In storing config files in source control, there are ways where you can say using different tooling that you're implementing. There's ways you can use tools to store this secret information securely and encrypted, and then populate the secure things that you don't want stored in plain text and version control using placeholders in those files, right? So always be, of course, very careful. Since this is a getting started demo, I went ahead and kind of did the anti-pattern in it. All right, so references for what we've covered. I hope you find the Git repo useful. I also have a cheat sheet on the Git CLI that you might find useful. And Rob Sewell has done a really, really terrific write-up of using GitHub, how to fork repos, how to use it to contribute to open source projects. Thanks so much for joining me for this simple introduction to Git. I hope it feels simple after you get your hands on it, after you actually start playing with it. I hope you have fun. I'm Kendra Little. I'll see you in another video soon. Bye, folks.